Google's Willow chip has quickly become one of the most talked about quantum computing milestones, not just because it broke a record, but because the scale of the jump is so dramatic that it forces people to pause and recheck what they think they understand about computers in general. For years, the public conversation around computing progress has sounded familiar. Faster processors, better efficiency, smaller components, more power packed into less space. Most breakthroughs arrive in steps you can picture, improvements you can measure, even if the engineering behind them is complex. But Willow, as it's described here, doesn't feel like a normal step forward. It feels like a door opening into a different category of possibility. The reason is simple, and it's also the part that hits hardest. Willow didn't merely edge past a previous record, it obliterated it. In the test it was given, the processor completed the job in under 5 minutes. The same task, according to the framing of this benchmark, would keep the fastest supercomputers on Earth busy for 10 septillion years. The comparison is so extreme that it stops being a matter of faster and starts becoming a matter of what does faster even mean in this context. Under 5 minutes versus 10 septillion years is not an ordinary gap. It's not a leap you can intuitively absorb. It's the kind of difference that turns a technical result into a cultural event, because people don't just hear it as an improvement, they hear it as a challenge to their sense of reality. To understand why the discussion heats up so quickly, imagine how this lands in a real-world setting. Somewhere, a test is set up. The chip runs. The output arrives in minutes. And then someone translates that performance into the familiar language of classical computing, supercomputers, years, scales of time we can imagine. Except here we can't imagine them, not really. 10 septillion years is beyond the span of human civilization, beyond the history of life, beyond any timeline that normally enters conversation. It's so vast that it almost stops functioning as time and becomes more like a symbol, a marker that says, this is not something a classical computer can realistically brute force in any meaningful sense. That's why the result travels so fast. Because it doesn't just sound impressive, it sounds impossible. And when something sounds impossible, people start reaching for explanations that match the emotional weight of what they've heard. That is where the conversation takes its sharp turn. Because the performance gap is so extreme, a handful of voices in the scientific world have floated a provocative possibility. Maybe this quantum speed looks almost supernatural because the work is, in some sense, spread across parallel universes, with calculations unfolding across multiple realities at once. That suggestion immediately changes the tone of the story. Up until that point, you can treat Willow like a powerful new machine. Advanced, cutting-edge, difficult to build, but still a machine. The moment parallel universes enter the frame, the subject stops being merely engineering and starts brushing against philosophy, physics, and the oldest human habit of all, trying to explain the unbelievable with ideas that feel big enough to hold it. It's important to be clear about what is being claimed in this framing, and just as important to notice what is not being claimed. No one is saying that Willow opens a portal, or that it literally travels between worlds in a science fiction sense. The idea being floated is subtler, and that's what makes it so unsettling. The suggestion is that the chip's behavior, or at least the way its power manifests, might be easiest to picture if you imagine computation not as a single chain of steps happening in one place, but as something distributed, something that can explore many possibilities in a way that feels like it's happening elsewhere as well as here. And this is exactly why it gets people talking, because it provides a mental image that seems to match the size of the result. Under 5 minutes versus 10 septillion years is such a violent mismatch that ordinary metaphors collapse. So the mind reaches for a new metaphor: parallel realities, multiple universes, an unseen expanse where possibilities can run freely. But notice the tension at the heart of this story. On one side, you have a milestone that appears, in the benchmark framing, to dwarf the best classical computing can offer. On the other side, you have the question: if the outcome is real and the gap is that large, what is the most honest way to describe what's happening? Is it simply a case of a new kind of processor doing a new kind of task more efficiently, still within one reality, still within a single here and now? Or does the scale of the advantage hint at something deeper, something stranger, something that makes it feel as if the computation is not confined to our usual understanding of a single timeline. This is where the documentary style of the story becomes crucial, because the goal isn't to sensationalize. The goal is to stand in front of the facts given in the file, what Willow did in the test, the stated time comparison, and the speculation that followed, and then follow the trail of human reaction as it naturally unfolds. When a machine produces a result that seems to compress a near-infinite amount of classical effort into minutes, the story is no longer just about the machine. It's about what the machine forces people to confront. One of those confrontations is the word computation itself. In everyday life, computation sounds straightforward. It means a process of calculation, step by step, operation by operation, reaching an answer through a chain of intermediate states. Even when the steps happen very quickly, the conceptual model remains familiar. But the Willow benchmark result, as presented here, pushes some researchers to ask uncomfortable questions about what computation even means. If the best supercomputers would take 10 septillion years in this benchmark framing, then classical computation looks like a road that simply can't be traveled in any practical sense. Willow, meanwhile, looks like it took a different route entirely, or perhaps like it didn't take a route at all in the way we normally imagine. That discomfort is not a sign that people are confused about numbers. It's a sign that the result seems to exist in two incompatible frames at once. In one frame, it's a physical device completing a task in under 5 minutes. In the other frame, it's a task so large that completing it classically would require a timescale that dwarfs the universe as we know it. The mind struggles to place both frames inside one picture. And when the mind struggles, it either rejects the comparison outright or searches for a bigger picture that can contain it. This is why a handful of voices begin speaking in the language of parallel universes. It's not necessarily because they want to be dramatic. It's because parallel universes functions like a container big enough to hold the emotional and conceptual weight of 10 septillion years. It's a way of saying, maybe the computation doesn't fit into one line of reality, one thread of time, one simple chain of cause and effect the way classical calculations do. And yet, even within that speculation, the core remains the same. The performance gap is the trigger. Under 5 minutes is the spark. 10 septillion years is the gasoline. Together, they create a story that can't stay purely technical because it inevitably invites questions about the structure of possibility itself. Think about how this sounds when spoken aloud in a documentary voice. Under 5 minutes. That is a phrase that belongs to modern life. It's the time it takes to make coffee, to scroll a handful of posts, to walk down the street. Then, 10 septillion years. That phrase doesn't belong to modern life at all. It belongs to the language of cosmic scales, of theoretical extremes, of numbers used to communicate not practicality, but impossibility. When those two phrases are placed side by side, they don't just compare machines. They compare worldviews. And that is why Willow is described as more than a record breaker. It's a milestone, yes, but also a mirror. It reflects back the limits of our intuitions. It forces people to ask, are we witnessing a new era of machines that can do certain tasks in ways classical computers cannot? Or are we misunderstanding the comparison itself? And if the comparison is valid within the benchmark framing, then how should we speak about a machine that compresses a 10 septillion year classical undertaking into minutes? This is where you see the story split into two currents, even before anyone says the words parallel universes. One current says, this is what quantum computing is supposed to look like at its most powerful, tasks that are effectively out of reach for classical systems, now done quickly because the underlying rules are different. The other current says, when the gap is that extreme, you should scrutinize the framing, the meaning of would take, the assumptions inside the benchmark itself. But even that skeptical instinct doesn't erase the central drama. Willow did the job in under 5 minutes. The claim stands in the file as a completed action, a finished run, a result people can point to. So the multiverse idea arrives not as a replacement for the result, but as an attempt to narrate it. And narration matters. When people say parallel universes, they are not necessarily introducing new data. They are introducing a way of holding the existing data without it slipping through their fingers. They are saying, if reality allows processes that look like this, Perhaps reality is larger than the single-lane highway our classical metaphors assume. That's why the phrase spread across parallel universes is so powerful in this context. It suggests distribution. It suggests that the computation is not an isolated sequence of steps happening in one narrow stream, but something that unfolds across multiple realities at once. Many calculations taking place in parallel, and the outcome arriving here as if the other work happened off-camera. And at the same time, the wording in the file keeps the idea carefully framed as a speculative possibility, something a handful of voices have floated, not a settled conclusion. That distinction is critical. The story is not saying that parallel universes have been proven. It's saying that the sheer scale of the benchmark gap has pushed some people to reach for explanations that sound as bold as the numbers themselves. In a documentary, this is the moment you would slow down, because it's easy for the audience to jump ahead and think the story is claiming more than it is. So you return to the anchor. What happened in the test? Under 5 minutes. A benchmark framed as requiring 10 septillion years for the fastest supercomputers on Earth. And then, the reaction. The sudden appearance of an idea that feels like science fiction but is being discussed because the result forces people to rethink what is plausible. And from there, the tension stays alive. It doesn't resolve cleanly because the story isn't allowed to add new twists. It can only deepen the view of what is already present. A remarkable performance claim and the unusual interpretation it provoked. The milestone is the engine. The uncomfortable questions are the smoke. And the parallel universe speculation is the flare that lights up the surrounding darkness, revealing how quickly a technical achievement can expand into a larger debate about reality. So when we repeat the central lines, we don't repeat them as filler. We repeat them because repetition is part of how human beings try to understand extremes. Google's Willow chip has quickly become one of the most talked about quantum computing milestones. So much so that it's pushing some researchers to ask uncomfortable questions about what computation even means. Willow didn't merely edge past a previous record, it obliterated it. In the test it was given, the processor completed the job in under 5 minutes, a task that, by the framing of this benchmark, would keep the fastest supercomputers on Earth busy for 10 septillion years. And that is where the conversation takes its sharp turn. Because the performance gap is so extreme, a handful of voices in the scientific world have floated a provocative possibility. Maybe this quantum speed looks almost supernatural because the work is, in some sense, spread across parallel universes, with calculations unfolding across multiple realities at once. Those sentences carry the entire story: the milestone, the scale, the discomfort, the speculation. Everything else in this expanded narration exists to make those sentences feel as large as they are, without adding new plot twists, without inserting new claims, without changing the essence. The result is presented as a single fact in this file, and the reaction is presented as a natural consequence of just how shocking that fact sounds. In that sense, Willow is not only a technical moment, it's a moment of human imagination being forced to stretch. Because when a machine compresses what is framed as 10 septillion years of classical effort into minutes, the world doesn't just hear faster. The world hears a riddle, and it immediately starts trying to solve it.